Greetings. A few years ago, we did a video on this Heathkit ET-3400 Motorola 6800 trainer. I had picked this up as a non-functional, and in that video we found out what the problem was. We fixed it, we ran some programs on it, and it worked great. And it still does. The problem is it's a bit underpowered, has a K of RAM, a K of ROM on it, and that even for that era, early 1980s, late 70s, it became kind of limiting. So what Heathkit did at the time was they released an expansion module for this. It kind of looked like a 3-inch tall pizza box that matched the footprint of this and basically sat underneath this, and you ran a ribbon cable from here to that box, and it gave you a total of 5K of ROM with lots of new goodies in it, 4K of RAM, a serial port, an RS-232 port, and a cassette interface. Now these are relatively easy to find. They're getting more expensive, but they're plentiful on eBay. But the expansion, which was called the ET-3400, is very rare. I guess not a lot of people bought these originally. They're expensive, and they're kind of clunky. They're just as clunky as this. I mean, it did the job, but you can't really find them, and they're a lot of money for what they give you. So I've been on the lookout for one, but I think one or two turned up, and they were very expensive. But about a year ago, I came across this. It was advertised as a replacement for the ET-3400 expansion. It was just a bare PCB. It was done by a fellow named Scott Baker, and I'm going to link to his information in the description. And it uses more modern components. It is obviously much smaller than the original ET-3400, which had the same outline, the same footprint as this, and was about 3 inches high in a metal box with its own power supply and a rather large PCB in there. And they're pretty rare to come by. I guess not a whole lot of people bought these originally. These themselves are pretty plentiful, but the expansion is not, and when it comes up, it is somewhat expensive, about $300 or $400. And considering it has the same old electronics in it that were used to make this, it seemed like something that I didn't really want to deal with. But this, if it in fact replaces that, not physically of course, but electrically, seemed like a good choice. Again, I ordered it, I got a bare PCB, but the GitHub, there's a GitHub for this, and it explains things pretty much in depth of how to put it together. Now don't expect the Heathkit type kit to come out of this, where it tells you to take a yellow wire, cut it to a 6-inch length, and strip 3/4 of an inch of insulation at either end, and then where to solder it to. You're kind of on your own. It is mostly obvious, but some of the minutia is not obvious, and you had to. But the schematic is supplied, bill of materials is supplied, And everything you really need is there. You just have to find it. So again, it came as a bare board, so you had to go and get all the parts. I had most of the parts. The part I didn't have was an RS-232 driver that interfaces between RS-232 voltage levels and TTL levels, which I got. And then there's another chip, which is a quad comparator, but it's an old Motorola part, which I ordered from the Democratic Republic of Cucamonga, and I'm still waiting for it. So we don't have that. So unfortunately, I'm not going to be able to demonstrate cassette I/O, because this is what's used to condition the cassette signal. But quite honestly, I was not willing to invest a lot of time into that part of it. So we're just going to go ahead and assume that the cassette I/O works on this. But what we have here is a bunch of jumpers to configure it for baud rate, where the power comes from, and just a few other things that are necessary. We have a 40-pin header here that connects to the header on the trainer itself. Next, we have an EEPROM that, I mean, the original EEPROM is still in the trainer, but this offers a much better monitor program and also a tiny basic implementation. This comes in for the 4K, for the total the memory, the static RAM to 4K, even though this is a 32K chip, but this was, I mean, I had one of these chips. It was, so it cost me nothing, even though most of the RAM capacity is not used here. All of the glue logic was combined into a GAL 16 V8. The JET file for this is provided on the GitHub page. The binary image for this is provided on the GitHub page. You got to burn your own. It has a 6821 PIA on it that reads some of the jumpers, but most importantly, it handles the serial communication by bit banging the outgoing stream and decoding the incoming stream. There's no UART on here. And there were some modifications you had to make to the trainer itself, and we'll get into that after we're done babbling about this. But that pretty much sums up what this is supposed to be doing. Here, of course, is DB25 for a true RS-232 connection, and the only thing remaining is there's a header supposed to go in here, so you can plug a Pi in there and have the Pi act as a terminal, hook it up directly to a monitor and a keyboard, and the Pi would basically replace the necessity of having a serial terminal. I wasn't planning on using that, because if you're going to start going that far, you might as well use a simulator on a PC for this whole thing. The whole fun is keeping it as close to the original configuration as possible. Now, there were two versions of this. The original version, which was the ET-3400, and then this one, which was the ET-3400A, which had, it pretty much used the same hardware, but it had some PCB changes that minimize the mods you had to apply to this. This is an A. On the non-A, you had to replace, well, one of the major upgrades was that the original one had a 2 megahertz crystal, which made the processor run at 500 kilohertz. But that needed to be replaced with a 4 megahertz crystal that gave you an effective speed of 1 megahertz on the processor. And then there were a bunch of things. Well, the first thing you had to do was this header wasn't installed. You had to install this, and you had to run some wires to it that were not connected, because when you have to use jumper wires, that usually means that they were unable to route those signals on the original layout. Since this is the second revision, the -A revision, the modifications were a lot less than what was required for the original revision of this. All you had to do on this was put in the 40-pin header, which you can see the underneath of, and wire the buffered data bus from over here to here, which connected it to the expansion connector. Now, Heathkit documentation is plentiful, and there is a document that tells you how to modify Rev 1 or Rev 2 in full detail, but those come with foldouts that tell you, especially the original Rev had a lot more wires and stuff that needed to be user installed here to make it talk to the expansion properly. And the instructions for this were there too, but of course the main instructions that told you that there was a big pictorial that showed you where to connect wires to, because the instruction just says, look at that pictorial and connect all of the wires. Well, that is not available. So what I had to do is basically guess what this needed and what it didn't. And to tell you the truth, I looked at the schematics and everything, but I still couldn't exactly figure out. I mean, I probably had to sit down and ohm out every connection, make sure that they were in fact connected, and if not, find out where to connect them to. But the big clue, or the Rosetta Stone in there, was this came with a kit of parts to modify your original trainer. And there were a bunch of wires and a crystal and just a whole bunch of things in there. And when you did a Rev 1, it said, hey, you're going to use all these parts. Now, the interesting part was that for the Rev 2, it said get rid of all the parts except for the 40-pin header. And there was also an 8 conductor ribbon cable in there that was 8 inches long. And that was the second part you were supposed to use, and not use any of the other wires, diodes, clips, whatever. So after looking at the old instructions, looking at the PCB and everything, I guess all I had to do was put in this connector and then connect 8 wires. And after looking at the schematic, the 8 wires turned out to be the buffered data bus. I ohmed out. There are pads over here to connect them to, ohmed out where they went to the connector, and after that everything fell into place. That's all you were supposed to be able, you were supposed to do, and then it was supposed to work. The most confusing part of not having that pictorial, well, it wasn't really in the pictorial, but one of the first instructions for modifying a Rev 1 and a Rev 2 were identical, and they said that you had to remove like 10 or 12 of these pins and just take them out. And I looked at that, and some of it made sense. For instance, we have plus minus 12 volts here, and it's not used by the expansion board. But they weren't really connected to anything on the expansion board. So maybe they just, I don't know, wanted to remove these so they wouldn't cause interference. But the main problem was there were other signals here that were definitely being used in the expansion, and the manual said cut them. So it just, that part didn't make sense to me. Obviously I'm missing something here, but I did not cut any of the pins, making sure, of course, that looking at the schematic of the expansion itself and double checking what the cut pins were supposed to be doing here. And yes, in fact, yeah, plus minus 12 wasn't connected, but the others were control lines, and the most obvious one was a 5 volt coming. Well, the 5 volts coming from the trainer, I guess that made sense because the original expansion had its own power supply on it, but some of the control signals just didn't make any sense, so I didn't cut any of them. And we'll see if I did the right thing or not. So let's go ahead and hook this thing up and see if I made the right choices. For our first test, we're just going to hook up the ETA through the ribbon cable to the trainer and see if the trainer still boots. Now, if it does boot, obviously it's a really good sign, because we know it's going to be using the RAM, ROM, and the PLD. Now, why do we know that? Because in order to run this, other than, of course, connecting it with a ribbon cable, we are instructed to remove the original 1K chips from here, which is very easy because they are socketed. And the reason these aren't used is it's using the SRAM on the expansion one, and it would have made the PLD much more complicated, so that it fetched its first 1K of RAM from here and then the other 3K from here, and that's unnecessary. So what we do is, we just remove those, and if we power this up and it comes back with the familiar sign-up message, that means most of this board is working. So 3, 2, 1, go. It does light up, and let's see, can we go to, if I remember this correctly, yeah, so it accepts commands. There's no sparks flying, no smoke rising. So there only remains one thing to be done here, and that is hook it up to a serial terminal and see if this guy will talk to it. So all that remains is for us to connect to a period incorrect terminal, serial terminal, which is this laptop over here. So we saw the setup with the ribbon cable going into it. We now getting true RS-232 output over here, going to this board hiding in the back, that if you've been following the channel is basically my go-to RS-232 to TTL serial converter, and that goes into USB over here, and then hopefully that screen over there will come alive when we turn this guy on. All right, the trainer's running, but it's still in the original boot up stage, running off of the internal ROM. And if we look at the terminal, there's really nothing there because we have to go to the extended monitor, which is sitting on the expansion board. And the way we do that is we use the do key on the keyboard, which really is a jump to, and enter the entry point in hex of the extended monitor, which is at 1400. And we can see that it puts up the monitor prompt. And now we should be able to type things in and make them work. So let's see, what is it? Memory 1400. And that lets you change memory or examine memory, I guess. Now, one thing I need to point out, you will notice that it's basically double spacing. And the reason for that is that whenever this terminal, the PuTTY, receives a carriage return line feed, so the carriage return should take the cursor back over here and then put the cursor one line down. But what it does was it deletes the first character in the line that it just carriage returned on. So it starts getting rid of information, which was extremely confusing to me, but I found this inelegant solution is that carriage returns are always automatically appended to a line feed, and even though the double, or in this case triple spaces it, you don't lose any screen info. There are other commands you can use, so let's get out of this. And yeah, that's kind of annoying. The magnifier keeps jumping around, but we should be able, I think there's like an instruction. Yes, it keeps to be annoying. This one's kind of interesting because it's like a binary disassembler. So if I say, show me the instruction at 1400, yeah, okay. So it's showing me the binary code. It's not really showing me the mnemonic, but if we keep continuing with this, it's actually smart enough to know how many bytes are in the next instruction. So it kind of does a binary disassemble where it is smart enough to know what how many bytes are in the next instruction, but there wasn't enough room in the ROM to show you the actual mnemonic. And then, of course, there's Tiny Basic that we can only enter from this monitor. And for that, we say go to, what is it, 1COO. So HTB1 means H Tiny Basic 1. And here's the basic prompt. So now there's nothing there. So now if we enter something, it's got to be in uppercase. It confuses the interpreter if you don't caps lock this. So now if we list it, it should show us that. There it is. This is running, by the way, it's at 2400 baud. It will run at 9600, but I brought it back to 2400 because I was thinking that maybe it's running too fast and that's why it keeps erasing column 0 whenever it line feeds, but that wasn't it. But 2400 is more period correct anyway. So there's our program. Now we can run this. Oh, and it'll give us an error. And the reason it gives us an error is it's expecting an end statement. So let's add the end statement. And then run it. And it should run and cleanly exit. And it does. And of course we can spend inordinate amount of times coming up with really cool basic programs and wiring up a circuit on the trainer itself and doing blinky lights and all of that, but that's out of scope right now. I just wanted to demonstrate to myself and to my audience that the expansion board actually works. And the last thing we'll do is there's a memory test in the expanded ROM, but the memory test doesn't use the terminal to talk to the outside world, but rather the 6-7 segment displays on the original trainer. So let's reset the camera angle and close up by running the memory test. Now, even though the memory test runs on the original trainer, the displays, you cannot invoke it from this keyboard, but rather you need to go into the terminal, exit Tiny Basic. You can't see that now, but basically by typing BYE, B-Y-E, that drops you back into the monitor, and then you go to a different address, which is 1A34, and it starts running the memory test. And the way that works is first it finds the top of memory, which is hex 1000 minus 1, the 4K that it's using. And then it comes up with an error. So basically when it stops, it says this value caused an error. Now it's putting the same value into every memory location, so we don't know where it happened. But obviously there's some, this memory is somewhat intermittent. So let's give this another try and see if we can get it to work again. So what we got to do is reset it, go to the monitor. I don't know, move the cable around a bit, maybe. And then on the terminal, say go 1A34, and it starts again. And so it is getting intermittent, and I kind of suspect it's the cable. So what happens if we pull out the cable here from underneath? Oh, and this time, okay, this time it actually, oh, it wasn't, it's actually giving us the address now of where the memory test failed. So let's do this one more time. And then I'll let you go, I promise. Go 1A34. So it failed again. And the article kind of warns you of that. It has something to do with the SRAM chip you're using on the expansion board. Even though it's recommended to use a 70, let's see, a -70 part. And that's what this is. But for completeness, let's see if we replace that chip if we can get the memory test to run reliably. Well, I replaced the memory chip and I kind of rerouted the ribbon cable, and we'll give it one last try here, but obviously with this cable mess I have and everything, things are not working too well. Even though, you know, basic ran, you saw that. So I'm not sure, is it because the way the memory test runs, or, well, let's see. We'll reset, we start the secondary monitor again, and then on the terminal we say go to 1A34, and it starts running. And after a while, it's still running, which is cool. Maybe I put down the ribbon cable just right, because off camera I tried it with the original chip and it ran for about half hour. So, well, no, there's too much stuff on the disk. There's interference here somewhere, and it ran into an error, but it generally works. And it's a cheap solution, well, compared to the original expansion, to have hours and hours of fun with this. So anyway, thanks for watching. Please like and subscribe and hit all the other right icons, and we'll see you next time.